Let's construct this graph nice and easy. This is the graph that they will give you. Okay. They told us that the particle started from rest and then accelerates to 20 meters per second. So it starts and then goes to 20 meters per second in 5 seconds. So it goes right here. Then they said it continues at this velocity for 10 seconds. So 10 seconds more, 5 plus 10 is 15. It then says, it then accelerates again uniformly to a velocity of 60. So it accelerates up to 60 in 5 seconds. So that's 20. And then it says what? It then decelerates uniformly to come to rest 15 seconds later. 15 seconds later is 35. Nice and easy. Okay. That's it. So first 5 seconds go up to 20, next 10 seconds rest, next 5 seconds go way up to 60, then 15 seconds it come down. It says now, find the total distance in meters traveled by the particle. Total distance traveled is equal to area under the graph. Total distance traveled is equal to area under the graph. So this is how we're going to break it up. We're going to break it up as, call this A. Let's call this B. Let's call this triangle C. And then let's call this D. So the total distance traveled is the area under the graph. So total distance is equal to A. Area of a triangle is half base times height. So it's going to be equal to a half the base of 5 times the height of 20. So it's a half the base of 10. Not 10, why do I write 10? Half the base of 5 times a height of 20, that give you A, plus area of this rectangle is length of 10 times the length of 10 seconds times the width of 200. So 10 times 20, which is 200, that would be area for B, plus C is a triangle with a base of from 10 seconds, from 15 seconds to 30 is 15. So the base is 15 and the height is 40. So this is plus a half the base of 15 times the height of 40. All right, then finally D plus D, and D is known as a trapezium. Area of a trapezium is a half the sum of the parallel sides. So it's a half this distance, which is 15, plus this distance down here, which is 20, times the perpendicular height, and the height is 20. All of this, when you put it in a calculator, will give you the total distance traveled. So the total distance is a half of 5 times 20 plus 200 plus a half of 15 times 40 plus a half of 15 plus 20 times 20. So this is 900. So the total distance traveled is 900 meters. So let's go ahead and do that now. We can write that down. The total distance traveled is 900 meters. So from the graph, we determine that. So part A, total distance traveled is 900 meters. That's the total distance traveled. Next it says find the average velocity of the particle. Now this is simple now, average velocity. To find average velocity V is equal to total distance divided by total time. That's average velocity, total distance over total time. Now the total distance is 900 meters. Total distance over the total time, that's average velocity. Total distance over total time. Now the total distance is 900 meters divided by the total time. And the total time is what? The total time is, I think, 35 seconds to come back down to rest. So 900 divided by the total time of 35, and that will give us the average velocity. And the average velocity is therefore 25.7 meters per second. Nice and easy, soft. Now part B, so this is now the real part B. Part B tells us that a particle travels in a straight line in such a way that after t seconds, its velocity v is given by, it tells us that the velocity of a particle is 3t squared minus 18, 3t squared minus 18, 3t squared minus 18t plus 15. That's the velocity of the particle. Now, if this is the velocity of the particle, what can we do? It says calculate the values of t when the particle is instantaneously at rest. The particle is instantaneously at rest when the velocity is 0. So when v is equal to 0, that's when the particle is instantaneously at rest. All right? Because think about it, instant rest means when you now move, like the velocity is 0. So all we need to do is at instantaneous rest, we set this equals 0. All right, so for part I, we set this equals 0. Now solving this equals 0, we can divide through by 3 to get t squared minus 6t plus 5, 6t plus 5, and that's equal to 0. Now we can then factorize this part equals 0. And so what is this? This is t, this is t, this is 5, and this is 1. This is saying signs are same, both of them negative. Minus, minus. So what this tells me then is t is equal to 1 or t is equal to 5. That's when the velocity is instantaneously at rest. Now it says the distance traveled by the particle between 1 and 3 seconds. So part 2. Part 2, the distance traveled between 1 and 3 seconds. So that is the distance traveled between 1 and 3 seconds. Let's call that distance s. S is going to be equal to the integral from 1 to 3. S is the integral from 1 to 3 of the velocity, which is 3t squared minus 18t plus 15. So when we integrate this, and remember we're integrating with respect to t. Integrating with respect to t. So when we integrate this, what are we going to get? We'll call the distance s. So integrating, we get Add 1 to the power, so we get t cubed, because it's really 3t cubed, but when you divide it by 3, the 3 is going to cancel. Minus 18t squared over 2, minus 18t squared over 2, plus 15t. And of course, we're going from 1 to 3. So when you plug in s as 3, what you're going to get is, plugging in 3, 3 cube is 27, so we get 27, minus, plugging in 3 squared, you get 9. Oh, my apologies, and I forgot to multiply. Let's say 18 over 2 is 9, and then 3 squared is also 9, so it's 27 minus 9 times 9, plus 15 times 3. All right, and then of course we're subtracting when we plug in 1. 1 cube is 1, minus, plug in t as 1, 18 over 2 is 9, so minus 9. Then 1 times 15 is 15, so you get plus 15. So this works out to be equal to 27 minus 9 times 9 plus 15 times 3. That's negative 9. Minus 1 minus 9 plus 15 is 7. So minus 9 minus 1 minus 9 plus 15, as I said, 1 minus 9 is negative 8. Negative 8 plus 15 is 7. And so minus 9 minus 7 is negative 16. Now, don't worry, distance, the negative 16 doesn't mean anything. So this is the conclusion. So the distance traveled is 16 meters in the opposite direction. That's all the negative mean. You're traveling in the opposite direction from where you originally started. That's all that means. Let's change the color to maybe red. So that's the distance traveled. Nice and easy. Now part 3 of the question. Part 3 says, find dv by dt when t equal to. So dv by dt is going to be when we differentiate v. So dv by dt is, when we differentiate v, it's going to be carried on the power. So we get 6t dv by dt minus 18. That's dv by dt. So C part 1, they want dv by dt when t is 2. So when t is equal to 2, what we're getting is dv by dt is equal to, we're going to plug in 2. Plugging in 2, what we get is 6 times 2 is 12, and 12 minus 18 is negative 6. That's what we get, negative 6. And then now for part 2, we're plugging in t equal 3. T equal 3. When t is equal to 3, we plug in 3 and we get 6 times 3. 6 times 3 and 6 times 3 is equal to 18. 18 minus 18 is 0. So when t is equal to 3, we're getting dv dt is equal to 0. All right. All right. Nice. Now it says, give an interpretation of this now. So give an interpretation. All right. So given the interpretation now, let's give the interpretation. So the interpretation is at t equal to the acceleration, dv dt is acceleration, so the acceleration is -6. So that means that the particle is decelerating. So that is, the particle is decelerating. All right, let's give an interpretation for part B now. So now at t equal 3, the acceleration is 0. The acceleration is 0. All right, that's what we know about t equal 3. And this wraps up the paper. Nice and easy. This was so easy. Soft, the capital T.